Hi, I'm Jayanti. I'm a participant of Postgraduate Certificate program of Cybersecurity by MIT xPro. As part of our Capstone assignment, we have been asked to perform a detailed analysis of the Equifax 2017 data breach and come up with defensive and offensive strategies. As part of this assignment, I'm playing the role of an employee that's working for an organization that deals with sensitive customer data with personally identifiable information. So this analysis will form a solid foundation to ensure that the company is well prepared for this kind of breaches, and it will form a foundation for strong security, cybersecurity governance and framework. So let's get started. So as part of this Equifax 2017 data breach, we've had the first detection happened on 29th July, wherein data breach affecting almost half of the US population, 147 million Americans, was detected. Customers' personally identifiable information was compromised, their social security numbers, date of birth, credit card details, driver's license numbers, etc. It was a zero-day vulnerability that caused this exploitation. It is CVE 2017-5638. It was publicly disclosed in March 2017. Malicious actors gained access to unprotected systems and data, and personally identifiable information was stolen. Post that, Equifax faced several legal proceedings, organizational leadership changes, resignations, and a $700 million settlement. This is an overview of the data breach. Now, coming to the vulnerability that caused the problem, uh, here's the vulnerability overview. The specific vulnerability was present in specific versions of Apache struts less than 2.5.10. This allowed attackers to send requests to servers by manipulating the content type header value in the request header, by injecting OGNL scripts into the content type header value. OGNL stands for Object Graph Navigational Language. With the help of this OGNL injection, the malicious actors were able to execute remote code and gain unauthorized access to the systems. Once the attackers entered the system through by exploiting this vulnerability through the web application, they could move laterally and steal sensitive data. They could disable firewalls and gain unauthorized access to many systems. Uh, Equifax web application processed sensitive customer data, and due to that, all the personally identifiable information was stolen. On 7th March 2017, Struts 2.5.10.1 version was released with a patch for this vulnerability. Here is a demo of how the exploitation could be done. This is a GitHub link of Metasploit. And here they are describing how a struts request can be sent through a method by manipulating the content type. Here we can see that the member access is being checked. If the member access exists, then it is being set to default member access. And if the member access does not exist, then it is being set in the struts context, and explicitly that member access, it is being created, the member access is being created, and it is being assigned default member access. Here we can see that OGNL is being specified to execute the script remotely. This is an example that has been provided by Metasploit. So here's the timeline of events that happened. I'll just zoom in a little bit. So on March 8th, US Department of Homeland Security notified Equifax to patch this vulnerability. The next day, on 9th March, there were internal communications between multiple teams of Equifax. Post that, the comms were not followed up and no action was taken. On 15th March, a vulnerability scan was done, but this specific vulnerability was not found. Post that, for 2 months, nothing much was done. And there is evidence to suggest that May 13 onwards, the vulnerability was exploited and unauthorized access was detected. This was not found until July 29. On 29th of July, suspicious network activity was investigated and blocked. The immediate next day, there was more suspicious activity, and the web app was made offline that day. Next day, on 31st July, the CEO of Equifax was informed, but they were unaware of stolen PII. As of now, it was only suspicious network activity. On 2nd August, law firms, forensic teams, and FBI were contacted to inform about this issue. And on August 11th, the external forensic team that was involved, they found that personally identifiable information was stolen. Those DB tables containing personally identifiable information were accessed. Documents were accessed by hackers. Post that, on 15th August, CEO of Equifax was informed of stolen personally identifiable information. Then followed a series of senior leadership meetings and board meetings from August 17th to September 1, which also included investigation, further investigation and assessment of the issue, as the forensic team had suggested that there could be potentially more attacks of a similar kind. So the network has to be prepared for that. On 4th September, the list of affected consumers was prepared, and planning was done for publicly announcing this issue. And FBI was also notified. Finally, on 7th September, there was a nationwide press release where this public announcement was made. Now, in terms of what went wrong, we'll first discuss the technical issues. It was a zero-day vulnerability, and a zero-day vulnerabilities is not always detected by regular vulnerability scanners, because sometimes there is a gap, some time gap between the database syncing up with the national vulnerability database, syncing up with the vulnerability scanning tools. So certain tools. So this should be ideally manually checked, specifically because the comms were made and it was a high severity vulnerability. It's evident that the vulnerability scanning procedures and tools were not up to the mark. Pen testing, which is an offensive strategy, it was surprisingly not done for 2 months. I mean, although the scanning could not detect the vulnerability, if the pen testing was up to date with the latest critical vulnerability, it would have been detected before the exploitation was done. It would have been detected before May 13th, between March and May. So this is one thing that went wrong. Now, in terms of defense in depth or security architecture flaws, there are flaws at multiple levels. The first level is application level. The specific vulnerability, even if the vulnerability fix was not provided, filter stack, a web app filter stack validation could have prevented the attack, because a simple validation of content type header would have prevented this. This comes under secure coding practices. In terms of network security, network intrusion and detection was not properly implemented. Multi-factor authentication implementation, this was crucial as access controls, as we had seen in the Metasploit demo. Access controls could have been modified without MFA. If MFA implementation was there, then this could have been stopped immediately. Then there were expired certificates. There were reportedly about 300 expired certificates, due to which it resulted in unencrypted communications. The data in transit was not encrypted. Hence, the data movement happened in an unencrypted way. There was a big data problem that was also highlighted in the references, that the big data was improperly handled and there were no proper data tracking procedures to see how the data is moving across the network, what is the source of the network, destination of the network, etc. So this is one of the reasons for delayed detection. Continuous monitoring was not in place. Monitoring and alerting tools, if they were in place, then as soon as the first suspicious activity was detected, users, the organization could have been alerted. Now, what went wrong in terms of process gaps? A zero-day vulnerability is a security vulnerability that is not uh, found by responsible disclosure. It is found only when real-world attacks have happened. So this is a critical vulnerability that should be prioritized, but it was not prioritized despite multiple communications. This is a process gap. Patch management process was inefficient. Communication gap was there between IT team, leadership team, security teams, and risk management teams. The cross-functional communication gap was there. There was lack of accountability in terms of both governance framework and in patch management as well. Senior management did not appropriately oversee the situation. Intrusion detection and network monitoring systems were not proper, and of course, there was delayed detection due to all of this and communication gaps. Now, the major missteps that led to all of this is there was delayed disclosure and there was non-transparent disclosure. The disclosure happened after 6 weeks after exploitation. The communication did not have proper choice of words, leading to customer frustration. There were many confusing terms and conditions. There were certain services that users could not opt out of, which were apparently paid services. And one major controversy emerged due to a wrongly worded statement or probably a confusing statement that required consumers to give up their right to sue Equifax in exchange for the service that they could utilize to deal with the situation. There were multiple legal proceedings, regulatory investigations, non-compliance. This resulted in legal fallout. And then there was a financial fallout, resulting in $700 million settlement to resolve the claims. In terms of incident response, the following could have been done differently. The patch systems should have been in place, and the containment of the vulnerability should have been done immediately. It was a high severity vulnerability, and critical and high severity vulnerabilities should always be prioritized. Network segmentation. Once the attacker gained access into the system via the Apache Struts vulnerability, network segmentation would have restricted their movement and prevented lateral movement across the entire network. And then, of course, rapid disclosure. This kind of an issue should be publicly disclosed within 24 to 48 hours, but there was a delay of months. There should be clear and effective customer-facing communication. The communication was confusing. The credit monitoring services should be easy to access, and it should have clear instructions given to customers and clear guidance on how to deal with the situation. Cross-functional teams should be effectively coordinated, and they should carry out this with proper collaboration. In terms of mitigation steps, we can view this in accordance with the NIST cybersecurity framework. The first one is proactive patch management. It involves identify and protect categories of cybersecurity framework. A dedicated vulnerabilities management program should be in place, and it should perform SS management, risk assessment, and it should ensure that any specific severity vulnerability should be given the proper priority. The second one is enhanced intrusion detection. This comes under detect of NIST CSF. Intrusion detection systems should be deployed, and security information and event management systems. All of these will ensure that any anomalies are detected in time. The systems are continuously monitored, and we have proper detection processes to ensure that any vulnerability is detected in time. Then network segmentation, as we discussed, it falls under protect, and it ensures that only those users that are allowed to access certain network zones will be allowed to access those zones, and it will ensure data security and access control. Now, coming to employee training, here secure coding practices was one of the problems that caused the issue. I mean, that could have mitigated. Of course, it was a zero-day vulnerability, but secure coding practices could have also prevented this. So secure coding practices as well as comprehensive employee training should be provided. This comes under protect, and there are multiple subcategories as listed here. Then we have multi-factor authentication. A lot of this problem could have been mitigated if access control modification and other important factors had multi-factor authentication enabled. And the next one is regular pen testing with regular updated pen testing with the latest vulnerabilities. Again, this forms an offensive strategy, and it comes under detect and response, detect and respond. This ensures that any anomalies or events can be detected, and responses can be planned, and it can be mitigated. Basically, the pen testing should not only be done regularly, it should also be updated with the latest vulnerabilities that have been publicly disclosed. Now, this is an example. This diagram has been taken from this link on AWS. This gives an example of AWS centralized logging. It deals with the big data tracking problem that was encountered by Equifax. As we can see here, there are multiple AWS services which are performing centralized logging into an Amazon S3 bucket, and it is triggering the required events and uh, doing whatever is required to further ensure the tracking end to end of where the data is moving from and where it is moving to. So this kind of an architecture where it is collecting the logs and triggering events, let's say, I mean, in this specific case, if we had some anomalies, then events would have been triggered to some other services, and the respective action would have been taken. So any big data problems can be handled with this kind of a centralized logging architecture. And this is just one of the examples in AWS. There are multiple such architectures. And all cloud providers have this kind of big data tracking methods. And something similar can also be implemented on premises in case any organization is working on premises. Key lessons learned. Organizations should always do timely patch management of specifically of publicly disclosed exploits. There should be strong cybersecurity architecture, defense in depth, and strong governance. Uh, Network should be continuously monitored, and the incident response team should be well prepared to deal with these situations. Communication should be proper, both cross functional as well as to the customers. It should be clear and transparent, and proper guidance should be provided to customers. Regulatory compliance requirements must be met, and proactive legal and financial risk assessment and mitigation uh, should be done. In addition, teams with strong investigative and problem solving skills must handle critical technical solutions. These are the references used for this presentation as well as the document. I hope the presentation was useful. Thank you.